Hi everyone. So today we will discuss one more algorithm that is also used for the authentication purpose, and the algorithm is secure as algorithm SHA-1. In SHA-1 we are using 160 bits as a output, or in SHA-512 we are using 512 bits as output. The input for this one is 512 bits, and the input for SHA-512, and the input is basically we are taking of 1024 bits. So again we will follow some steps here. So first step is the pad the bits. So how to pad the bit, we will understand this concept. So pad the bits so that the length of plain text the length of plain text is 64 bits. Okay, then so you just understand this one, what I'm saying. This is our we are taking this is our plain text. Okay, so we are just adding some padding bit over here. Okay, so now what is the length of this one what is the length of the message, and if the length of message is determined, then what is the length of this padding. So we will understand very soon this concept in our second step. So what is our second step? Append 64 bits as representation to original plain text such that the length of message, so length of the message would be multiple of 512 bits. Okay, so we need to append for 64 bit. So now understand, this is our message as like this one. Now we have padding over here already we have done. Now we need to add additional 64 bits. Okay, so now 64 bit is over here. Now let's take the message size is 400. Now what is the size of padding we need to apply? Okay, so understand this concept. Let's take the plain text size of 400. Already we are taking the size of the plain text is 400. We do not know the padding size, but we know 64 bit we have added in second step. So it must be the multiple of 512 bits. Okay, the addition of these three must be the multiplication of 512 bits. This is the condition that we need to satisfy over here. So to calculate this one, what you need to do, there are different things that we have applied, but I'm telling you a very simple way. You need to add these two bits. 400 plus 64 means 464. Now subtract 464 from 512. So 512 minus 64 equal to 48. So now this will be our padding size. You can see over. So now 400 plus 48 minus 400 plus 48 plus 64. Now it will be equivalent to 512. Okay, so the addition of these two is 512, and we have already written here the length of this one. The length of this one either multiple of 512 or multiple of 512. Okay. It will the multiple of 512. So in this case what I mean, it is 512. Okay, suppose it is 1024, then it will be the multiple of 512. Okay, that's why I've written it is either divide and divide. We can divide this one with 512, or it will be the multiple of 512 bits. Okay, so in this case you can understand it is quite easy. Okay, now let's come to our next point. So what we have determined message padding and message we have taken 400, padding value we have determined. So this part we have determined. Now third step is our initialization of buffer. The buffer here, so there are 5 registers we are taking, A, B, C, D, E, and it will contain the hexadecimal value 32 bits, and the size of each buffer, each register is 32 bits, and it is a form of hexadecimal. Now why we are taking 32 bits over here, then how to represent this one? So to understand this concept, I have taken a very simple example. There 5 registers I have taken. Okay, A, B, C, D, E. Now I am taking these hexadecimal values. So there are how many values are there? You can understand there are 8 hexadecimal values are there. 1, 2, 3, 4, 5, 6, 7 and 8. Okay, so when we convert this hexadecimal value into binary, that we know we need to take 4 bit for each value. So for this value, hexadecimal value, 4 bits we need to take. So what is the binary equivalent of this one is 0101. Similarly for 3 you can see 0011. Equivalent of this one B is 1011. So there are total 4, there are 8 values are there in hexadecimal. For each value 4 bits are required, so total 8 multiplied by 4, so total 32 bits. Similarly for B, C, D, and E. So 5 registers are there. In each register 8 hexadecimal value we are taking, and the binary equivalent of this one would be the 32 bits. Okay, so this is clear now. So now let's come to the next point. So now we have initialized our, sometimes we are calling this one as initialization vector. So ultimately we are having 5. So randomly you can take the value of A, B, C, D in hexadecimal format and you can initialize with them. Okay, so how it's come to 32 already I have explained. Now come to here. 512, the message size we have already seen that it is our 512 bits that we have calculated over here. Okay, the size of message plus padding plus representation of bit here 64. So the addition of all these two now become 512. Now we are taking this one as it is in our next section. Okay, so we will apply this message scheduling over here. So similarly this will happen in MD5 and you can see in 512, SHA 512. The same step we need to do. So up to here concept is same. Okay, so if you have any confusion in MD5 and SHA 512, then you can start from here. Okay, so now come here. So during the message scheduling, so there are how many, as we have seen in this diagram, there are 0 to 79 rounds are there. Means round 0, round 1, round 2, so up to 79 rounds are there. So total we can say 80 rounds are there. W0 to W79 rounds. In each rounds there are in each round one word is needed, and the size of this word is 32 bits again. Okay, so how many words are needed? 79 words are needed. Okay, so now let's understand how to generate this 79 words. Okay, so message scheduling. So what is the size of our message? 512 bits as we have seen, and the size of this word is 32. So what you need to do, 512 divided by 32 means 16. Means how many words we can generate? 16 words. So how to take this one? So now you can see 16 words we can take: W0, W1, W2, W3, W4 up to W15. So how? So in our message side there are 512 bits are there. So initially 32 bit will take and we will store this value into W0. The next 32 bit will take and we will store into W1. So पहली initial value आपको 32 bit W0 में store करनी है, उससे next 32 बिट W1 में, उससे नेक्स्ट टू नेक्स्ट W2 में. तो इस तरह हम W15 तक वैल्यू अपनी जनरेट कर सकते हैं. नाउ व्हाट अबाउट W16 टू W79? Okay, 16 values, 16 words we have generated. Now what about W16 to W79? So let's understand. So I'm writing here W0, W1, W2 up to W15. Okay, now W16 to W31 I'm writing here, W32 to W47 I'm writing here, and now W48 to W63 I'm writing here, and W64 to W79 I have written here. So now the value of W0 allowed to W16, W32, word 48 and word 64 means word W0, W16, W32, word 48 and word 64. It will contain the same value. Similarly, this column will contain the same value, means W1, W17, W33, W49 and W65. All these will contain the same value, because how many values we are having? We are having only 16 values, and now we can say the 5 word will contain the same value. Okay, here these 5 words will contain the same value, here these 5 words will contain the same value, here these 5 words will contain the same value. In this way we can generate our 79 words. Okay, hopefully you are you are getting me. So now again come to this our block diagram. So message size we need to generate 79 words from W0 to W79. So words we have generated. Now next one is, in each round one word is needed, and these are the buffer are needed. Now next one is the constant is needed. One constant is needed. There is some constant is needed, and how many constants are needed? 4 constants are needed, and the size of each constant is 32 bits, and it also contains the hexadecimal value. Okay, so as like our buffer, you can see here I have initialized the 4 constant values k1, k2, k3, k4 with some hexadecimal value. Randomly I have selected and I have initialized their value. Okay, so principle will remain same. 32 bits are there as like our buffer. So now only for now this concept, the message scheduling part we have learned, and this one in this the word and the buffer value needed and constants are needed. Now you can say there are 80 rounds are there and we are using only 4 constant value. How it is possible? So let me tell you how to take this one. I am taking 4 sets are there, set round 0 to 19. Okay, so round 0 to 19 I will take. So what are things are needed? One constant, buffer and word. So for round 0 to 19 I will take word 0 to 19 and I will take the constant 1, k1 I will use here. So 20 राउंड्स के लिए आपको K1 यूज करना है. सिमिलरली राउंड 20 to 39 these 20 rounds you have to use constant K2 and round 40 to 59 you have to use constant K3 and round 60 to 79 you have to use constant K4. Okay, so now it is fine. 20 राउंड में आपको K1 यूज करना है इनिशियल 20 में, उसके बाद आपको K2. सिमिलरली 20 राउंड्स में तो 4 सेट्स है, तो उसमें हर राउंड में आपको एक कांस्टेंट यूज करना है. सो नाउ यू कैन सी हियर कांस्टेंट इज रिक्वायर्ड फॉर ईच राउंड, buffer value required, word required. So now we have seen the concept of all this. Now very soon I will put you that block diagram where we will understand this one. Now one more thing is over here from this diagram. As you can, this is our initialization vector. This is our our initialization value will come, and after the 79th round the value of this one 32 bit we will take from here, and we will take some value from our initialization vector as you can see from here. And now this value we will insert here, and we for each 32 bit value come here and 32 bit value come from here. Now 32 will value come from the 79th word, and similarly for each and every, because there are 5 buffers are there, the 5 values we will take, and finally we will apply the addition modulo. Why we are applying? If any carry, as we know, after the addition the carry may be generated, there is maximum possibility to avoid that carry. So what happen if the carry is generated 32 bit, will convert it into 33 bits. So to avoid or to reduce that additional one bit, we need to take our addition modulo operation we need to apply. So ultimately our final output will come 160 bit. If this is the single block is over here, then it will be our hash code. If there are multiple blocks are there, suppose there are 2 blocks of 512 bits and 512 bits. Now for our first, suppose this will become our H1 first H code. Now this will be the input, and this output of this round can be given as input for the next 512 blocks. So तो next round के लिए ये आपका input बन जाएगा. इसके लिए input था आपका initialization vector जिसको हमने randomly initialize किया था. तो next अगर 512 blocks का अगर एक और block है, आपका plain text अगर 2 या 3 4 अगर ज्यादा है, तो ये एक साइक्लिंग चेन प्रोसेस बन जाएगा. तो इसका आउटपुट नेक्स्ट के इनपुट में जाएगा. दैट यू हैव टू कीप इन माइंड. ओके, नाउ one more thing is over here. As you can see, in each round I am using, suppose you can see F1, F2, F3, F4, 4 functions I am using coming here. Now understand from this block diagram. Let me set the camera first. Yeah, so there are, the input is 160 bits. Already we have initialized 5 register. So now you can see A, B, C, D. These are the buffer values that we have initialized. Okay, so randomly we have initialized. These are the values that we have initialized. Now what we are doing? We are taking this function value, some function we are also applying. So for round 0 to 19, for initial 20 round, we are applying the function F1 on B, C, D. So these are our logical operation that we need to apply. That what is this one? B के साथ end होगा, B and C का end होगा. इधर B का नोट होगा, उसके बाद उसका D के साथ end होगा. Finally we will apply the OR gate in F2 functions. तो F2 function कहाँ से कहाँ रन करेगा? Round 20 to 39 in which apply. So this is the value you can see. So we are taking the value B, C, D, or B, C and D. So in the initial 0 to 19 round we will use F1 function. This one function we will use. So I have written here round 0 to 19 we will apply the BCD function. Okay, and what is the value we will use? Constant K1. Okay, for round 0 to 19 F1 function आपको use करना है, constant K1 रहेगा. For round 20 to 39, we will use function f2. And what is this one? B with XOR with C, and output of this one will be XOR with D. And now we will apply constant K2, that I have already explained. So similarly we apply F3 and F4, and similarly we can go for the constant K3 and K4. Okay, so these are the functions. Now you can see one more thing in this block diagram. We are taking the value of BCD. Okay, now we will for round 0 to 19 we will apply F1, the logical operation. We will apply logical operation function over here, and the output of this one goes to over here, and we will take the input from E, and then we will apply addition modulo. Now come to the next. The output of this one goes to the next addition operation here, and now we are taking the value of A. Now what is this one? We are applying in the A register. How many values? 32 bits are there. Out of 32, we are applying 5-bit left shift operation. Means it contains 32 bits. So we will 5 bit आपको शिफ्ट करना है यहाँ से. तो यहाँ से जब 5 बिट्स का शिफ्ट करोगे तो यहाँ से 5 बिट वैल्यू निकल के यहाँ ऐड हो जाएगी. Okay, so ultimately this file will remain same. Okay. Then output of this one goes to, we will apply the addition module over here. Then finally our word is ready. So 0 to 19 with F1. For word 20 to 39 we will take F2. Word 40 to 19 we will take F3. And word 60 to 79 we will take F4. Now similarly we will go for each and every round K1, K2, K3 and K4 as per our discussion already I told you. Then word K finally, and after this addition modulo we will store this value into A. Okay, now B, whatever the value of inside the B, inside A, we will store as it is in B. Now in C में direct नहीं आएगा. इसमें what we have to do, we need to shift 30 left circular shift with 30 bits. After that the value we will store in C, or inside C we will directly take inside D we will take directly value of C, as you can see. Inside E we will take directly value of E. If so, this is the working block diagram. How this how we are using the constant word and word logical function and our buffer. Okay, so all these things has been combined over. In this way, our algorithm is going to be executed in each and every round. This will be executed for each and every round. After this, we will calculate the value of hash. Now we will attach this hash code with the hash code value with our message, and we will send this value to our sender. We will send this value to our receiver. Now receiver will receive this message from the network, and he will apply the same algorithm at the receiver end, and he will also calculate the hash value, and finally he will match the value of h calculated at his end and the hash code value sent by the sender. If it is coming same, then he can say it is an authentic user or valid user. If it is not, if any single bit is different, then that value will be different. Okay. So if you have any query, then let me know. Okay, thank you.